right. Hello, hello, hello.
Okay.
Hey.
Does either of you go like this when the explosion happens at the end of the intro?
It's
I
very
think it's just you.
I think you're the only one that does that. But I do definitely move around while it's going, for
Yeah.
sure.
I just dance, yeah.
Yeah, absolutely. So awesome. So how are you guys doing?
I'm doing great. As I was saying offline, though, just forgive me if I'm a little bit off. I was working on a very perplexing report today, so my brain is just a little bit fried. So hopefully in the morning with a fresh start, I'll get it finished up. But I was just like, I've had enough.
Yeah, so we get
Well,
to dive into some more perplexing material.
Yeah.
So awesome. And how about you, Kim? How you doing?
I'm good. Just working Monday, Wednesday, and Friday this week. So it's kind
Yeah.
of like, I don't know if I'm coming or going.
You
I don't
know,
even know what day it is. I
you-
keep thinking it's Friday.
Do you like working more consecutive days? Or
Yeah.
yeah.
I mean, I like to work two together. Like, I usually like to work Monday, Tuesday, and Friday.
Yeah. That's what I used to do. I'd used to do two together, and then I'd have a day or two off, and then I'd do
Yeah. I don't like 3 or 4 together. It's just too much.
yeah. By the end of the second shift, these 12-hour nursing shifts, you've pretty much worn
And
yourself out.
if I leave my house for 3 days at a time, I mean, it's hard to get back to get everything back working again, you know?
Yeah.
Yeah.
Yeah. That's one good thing about nursing is that you can have a decent balance because you can have 4 days off a week.
Yeah.
Yeah. So that's cool.
Yeah, I mean, one of them is usually recovery.
True.
But
Yeah. Well, when I was really sick, all of them were recovery. Like
Ooh,
I had
yeah.
nothing left to give besides, yeah. So, all right. Well, for anyone who's new, this is our Keto Study Club. This is it's a medical textbook, and we are crazy, and we're going through this. It's called Ketogenic: The Science of Therapeutic Carbohydrate Restriction in Human Health. And unlike a book club, we don't read ahead. We just read and discuss as we go. And we have been doing this. This is our 30th session.
yay!
This is how far we've gotten so far.
That's all right. It's a good excuse to get together and talk about just various things.
Yeah,
It's all good. You guys are my friends.
That's
I
right.
know.
We read a little, we gab a little, we try to figure some stuff out a little, and eventually. So we're on chapter 3, or no, this is chapter 3, right? Yep, the endocrine system. So we are still on this section on metabolic syndrome, and last
page 118.
Yeah, so we're on page 118. Let me just look and see if it looks like I'm going to pull up my PowerPoint just in case we get super ambitious. And we're actually, so we would be on that one slide if we get to it. So
we might get there. I don't know. I can start if you want.
Yeah. Sounds
that
good.
Way I'm fresher. Okay. So maybe, by the time this is over with, I may be going blah, blah, blah.
Yeah, and we've got Amy here. Hey, Amy. Good to see
Amy.
you.
Hey, Amy.
All right, so you go ahead and start.
All right, so we're on page 118. So it's obesity and insulin resistance at the top of the page there. The role of insulin in the skeletal muscle is predominantly glucose intake. In the liver, the role of insulin is to regulate metabolism of all nutrients. WAT, refresh my memory. What is that?
White
adipose tissue. Okay, white adipose tissue is exquisitely sensitive to insulin stimulation and seems to play a central coordinated role in crosstalk between various role players, including liver, muscle, central and peripheral nervous system, and the gastrointestinal tract within minutes of nutrient intake. That's pretty amazing to me that it's that fast. Many studies have shown that consumption of calories in excess of nutritional needs in a non-obese, non-diabetic person results in a marked resistance to insulin action. Insulin sensitivity has been well documented to decline with increasing body weight. The resultant hyperinsulinemia progresses to insulin resistance, which further stimulates adipocyte hypertrophy, resulting in inflammation and worsening insulin resistance.
Yeah. So your adipocytes, which are your fat cells, become enlarged. So it's not like we're necessarily it's not like we're necessarily just like creating extra fat cells. The fat cells are just getting bigger, and that's why we're getting fatter.
And there are some people who actually do create extra fat cells, and then they don't get insulin resistant. They just get bigger. The people who create the fat cells. But then I saw a lecture by Craig Emmerich that really explained that. He was at Low Carb for Better Health a couple years ago and explained how that worked out. So two overweight people, one might be insulin resistant because their fat cells are actually bigger. And then the other person, which is more rare, most people, their fat cells just get bigger.
Yeah. I think that's me, because I did become insulin resistant and then pre-diabetic.
Mm-hmm.
So
yeah.
So it's just interesting how even though like two people might look similar in body type or whatever, that their composition is just totally different.
Yeah. But it's cool that the insulin, it says it's the role of insulin is to regulate metabolism of all nutrients in the liver. So it's actually, like we talked about earlier on in the book, it has a benefit. We need insulin. It's not like insulin's the bad guy.
Right. Because if you don't have any, you're in trouble.
Yes, it's just excess.
Yeah. And it does more than just store fat.
Right. Yeah. Yeah.
I mean, it does more than just store sugar. It does other things too.
Exactly. So.
All right. So the next part is dyslipidemia and insulin resistance. Several studies highlight the relationship between carbohydrate intake and dyslipidemia, with smaller, denser lipid particles being directly associated with increased risk of cardiovascular disease. Elevated triglyceride concentrations have been shown to promote the formation of small, dense lipid particles, and elevated triglycerides are associated with hyperinsulinemia. So that's why they always talk about, like, if you have low triglycerides and high HDL, for example, that you're better off.
Yeah, and when after I cut out all the carbs, my triglycerides went cut in half.
Yep.
Yeah.
Yep. Same here.
Yeah.
Under normal circumstances, LDL cholesterol is synthesized from hepatic-derived VLDL by progressive cleavage of lipids and apolipoproteins, and IDL formed in this process are particularly atherogenic. It follows that factors which promote VLDL synthesis will also result in higher IDL and LDL concentrations. So that makes it so factors which promote VLDL synthesis also results in higher IDL and LDL concentrations. Okay. Plasma VLDL concentration is determined by the rate of liver VLDL synthesis and the rate of VLDL removal at the peripheral tissue level. Serum insulin concentration and nutrient substrate availability are responsible for VLDL concentration. So how much insulin you have relates to.
So I wonder if they're looking at concentration of VLDL basically like in a blood sample. I mean, does that equate to quantity? I'm assuming that means concentration in a blood sample.
What is IDL again?
Good question. I I don't remember.
Hold on, I'll look at it. Okay.
Do they have an acronym?
IDL and VLDL are both types of lipoproteins involved in lipid transport, with VLDL, very low density lipoprotein, carrying triglycerides and cholesterol, and IDL, intermediate density lipoprotein,
Oh, okay.
being a product of VLDL after some of its triglycerides have been removed.
Okay. So
IDL can
broken down.
IDL can be further converted to LDL.
Okay.
So it's like a precursor to LDL, maybe, or
yeah. So as VLDL, I think as VLDL goes out into the body.
Oh, I've seen those diagrams, the cycle.
Yeah, it gets used and it releases. As it releases triglycerides, then there's an intermediary form, and then there's the final like LDL form.
Yeah.
So
yeah, I've seen those charts before where it goes through the whole lipid cycle.
Mm-hmm. Yeah. So interesting, because it says it's removed. It gets removed at the peripheral tissue level. So I guess it's done then. It's done its job.
Okay. So over short periods of time and in controlled amounts, insulin suppresses VLDL production. However, in the setting of prolonged insulin secretion and hyperglycemia, the resultant hyperinsulinemia causes hepatic insulin resistance and hepatic de novo lipogenesis. So, okay. Triglyceride synthesis is enhanced as well as raised triglyceride-rich VLDL, and VLDL clearance peripherally is inhibited. So the hyperinsulinemia prevents the clearance of the VLDL.
Mm-hmm.
Okay. In addition,
and it enhances. Let's see. It also enhances triglyceride synthesis, so it does both. It makes the triglycerides higher, and it inhibits the VLDL clearance.
Mm-hmm. In addition, increased insulin and glucose concentration upregulate. Okay, don't remember what this is. Not all of it. HMG-CoA.
Is HMG that human gametotrophin or
HMG? Hold on.
I myself I need to create my own little acronym list here.
It's it's a coenzyme. Let's see. What does it stand for though? 3-hydroxy 3-methylglutarryl coenzyme A. It's a crucial metabolic intermediate in various pathways, including cholesterol biosynthesis and the breakdown of branched chain amino acids. It's synthesized from acetyl-CoA and acetoacetyl-CoA and acetyl-CoA, and is a precursor to mevalonic acid, a key molecule in the cholesterol synthesis pathway. HMG-CoA is also a precursor to ketone bodies and is involved in the metabolism of the amino acids leucine, isoleucine, and valine.
So that's when your ketone levels go up. I think that's the one where like people will smell that acetone kind of. I've actually had that on my breath before. Like, had that acetone.
You got the fruity breath.
I've never noticed it in my breath, but I know immediately from my urine smell.
Yeah, that too.
I go into ketosis.
Yep.
Yeah, I do too.
Okay. I guess the word pronouncing that whole thing, I'm just going to say HMG-CoA.
Yeah, sounds good.
Okay. In addition, I'm going to start this sentence over then. In addition, increased insulin and glucose concentrations upregulate HMG-CoA reductase activity, resulting in increased cholesterol synthesis.
Okay.
All right. So the next section is hypertension and insulin resistance. Now, this will be interesting. As far back as 1988, Gerald Reaven proposed a link between hypertension and hyperinsulinemia in his Banting lecture. Several studies have since shown that patients with hypertension also have hyperinsulinemia and insulin resistance. Moreover, when insulin sensitivity improves and serum insulin concentrations are lowered, blood pressure has been shown to reduce. Although there is strong evidence of correlation between hyperinsulinemia, hypertension, and insulin resistance, some population studies could not show a significant relationship. Now that's interesting.
Speaking of hypertension, this is completely not on topic, but it just brought up something. So I had a teeth cleaning yesterday at the dentist. For the first time ever, at the beginning of my appointment, they took a blood pressure reading. Like, seriously? Who's going to have normal blood pressure right before a dentist appointment?
Right. I've had them take it before they've done like work, like before they do all the needles and stuff, but I've never had them do it before a cleaning.
So I've never had them do it at all.
They had never done that before. And I told them, and so here my blood pressure was like 148 over 93.
Oh,
and
geez.
I said, does this really like mean anything to you guys? She goes, not really. Most people are high when we take it because it's a dentist.
It's like, hey, put me on the gas and then take my blood pressure.
Yeah, because it's like whenever I check it at home, it's like 110s over 70s. And they didn't even wait. I mean, so she did have me not cross my legs, and I'm laying back in the dentist chair, but only for like a minute. So it wasn't even really enough time to really evaluate my resting blood pressure. But I'm like, yeah, I don't think so.
And they don't always do it before dental work. So I'm not sure if it's depending on what they're doing. Like if it's a root canal, maybe they do, but if it's a filling, they don't or something. But I know they don't do it every time.
That's weird. I've never had them do it.
I had never before yesterday. This was the first time. And she says, yeah, they want us to do it. And we'd always forget. And I'm like, well, because then what are you going to do when you got all these people with high blood pressure? Then what are you going to do?
Well, they're probably wanting to make sure it's not too low.
Probably. Yeah.
Maybe. Could be.
But for teeth cleaning, they weren't giving me anything. They were just cleaning my teeth.
I mean, I don't know. That's like if they're not giving you anything. Anyway, it's probably some sort of benchmark that they have to
probably
just a checkbox that they have to mark
for insurance, Medicare, or something like that.
But I mean, with this working in, when I was working outpatient, if we had people that had blood pressure that was high, we couldn't just not do anything. We had to at least do a follow up, and check it again. And if we
you could refer them to their family doctor.
Yeah. And if it was still high, tell them to go get in with, go check with their primary doctor and follow up with them. So it's not like you could just do nothing.
Yeah.
So, okay. Anyways.
So, I'm with you. I don't really know what the purpose is other than maybe if it's too high, I guess they would.
I'm sure it's just they try to be as deep into your business as they can possibly be. And they take on this more liability by doing that,
that's exactly.
But they want us to make sure that nobody's getting ready to commit suicide. Nobody's, smoking. Nobody's, all these things. Nobody's fallen lately. And granted, yes, is there good in that? Sure. If there's somebody who's totally helpless and they need to be, that needs to be caught or whatever, sure, we could possibly help that one person. But for most people, it's just really invasive and weird. Because they would ask me in my 30s, have you fallen lately? I mean, what reason would I have to, it's just, It just usually doesn't.
And if you were falling for no good reason, you'd be going to the doctor about it probably.
Yeah,
This isn't
and
why you were
am I
on.
coming to a regular doctor's appointment to catch my thoughts of suicide? Like, am I even going to be honest about that?
I was
know.
thinking the same thing. A lot of
It
people
just
wouldn't
seems
be.
like it seems like they're just like everything's about like liability and like we're in charge of the whole person. Like, this is a whole person that does not need my intervention that much unless they ask for it, And don't get me wrong, I'm not saying that we shouldn't try to help people, but it just gets to be like 90% of your visit, they're going down doing their little check marks instead of actually looking at you and saying, "Hey, Carrie, by the way, what did you want to talk about?"
Yeah, why are you here versus checking off all the boxes?
Well, the person asking you is, at least at a doctor's visit, is a medical assistant.
Mm-hmm.
It's not a nurse or a doctor.
Well, anyway, in the hospital, we have to ask people, like, for the first, I can't remember exactly what the criteria is, but we have to ask them multiple times during their visit if they have thoughts of hurting themselves.
Oh, really? We only had to do it once.
So weird. I don't know.
Weird.
It's very
we only had to do it at admission.
Yeah, it's like, it's more than once now. It's like, I can't remember because, I might be guilty of not exactly.
On Coach Lisa's program, I'm supposed to eat a whole stick of butter today.
Oh, Lord have mercy.
I've done that many times, eating a whole stick of butter. Like, once in a while, I'll just crave it, and I keep a stick in the refrigerator separate from the rest of my butter that I actually just take bites out of.
I would be on the toilet all day.
I might be tomorrow.
I would eat like 2 little pats of butter, and I would, be on the toilet.
Isn't that funny how we're just all different?
Half of it went in with my lunch, so I'm just trying to meter myself eating the rest of it. So, okay, sorry. I got us off track.
All right. So, the mechanism for hypertension in hyperinsulinemic patients is postulated to be the direct effect of insulin on the sympathetic nervous system, as well as an increase in renal sodium retention. The theory of renal sodium handling is supported by many studies, including recent work by Dr. David Unwin. Insulin promotes the renal reuptake of sodium and consequently fluid at the level of the tubule. Insulin is also believed to have a role in hypertrophy of vascular smooth muscle related to mitogenic action of insulin and the mitogenic arm of the
insulin receptor.
Thank you. Okay. The mitogenic action of insulin and the mitogenic arm of the insulin receptor. Okay, so what that is saying, insulin promotes the renal reuptake of sodium and also fluid at the level of the tubule.
Yeah, and so when you're talking about hypertension, those the sodium in the intravascular fluid are, associated with hypertension. Can be.
Yeah. Okay. So then hypertrophy via insulin action results in increased myocyte size and number, as well as increases in contractile protein, collagen, and DNA. The resultant narrowing of the vascular wall has been thought to contribute to insulin-resistant hypertension.
Okay, so is this what they call hardening of the arteries as opposed to plaque buildup? Because I know there's plaque buildup that can cause narrow arteries, but this is not talking about that.
No, it isn't.
This is different. So this is talking about a narrowing of the arteries, but through a different mechanism than plaque. What do you think, Kim?
Yeah, I would guess that's probably, it could very well be it.
I don't
I've
remember.
always wondered, like my mom always talks about hardening of the arteries, and I'm
My
like,
mom did too.
they literally never talk about that in medicine at all. I've been
No.
literally never heard of anybody having hardening of the arteries.
Right.
I don't know.
I hadn't either, but I don't remember.
Google what it means.
But
Like-
I do know that if you have plaque in one place, they're just finding it in your heart because they're looking for it in your heart. Like you've got it
Yeah.
other places. So I just always associated it with that.
Yeah, except this is talking about narrowing outside of the realm of plaque for a different reason.
But is it a temporary narrowing, like say, like in how your vessels will do that, like they'll dilate and constrict, or is it talking about like
I'll bet you that's what it is. That it does it as long as that condition is present, and then if, like for example, then if you once that insulin action is not, once that's out of the picture, then that narrowing doesn't happen anymore.
Yeah, so it says the resultant narrowing of the vascular wall has been thought to contribute to insulin-resistant hypertension. So there's specific.
Yeah.
I have never heard any doctor talk about, oh, this hypertension is from insulin resistance.
Nope. But they'll tell you, don't eat sodium.
That's right. They'll tell you to get back off on the sodium, but heaven forbid we just get the insulin resistance under control so that the kidneys don't retain the sodium.
And then they'll tell you not to eat red meat too.
And then the thing is if you don't have hypertension, you don't have to worry about, like, this is not medical advice, folks, but I mean, I've never known of anybody having to worry about sodium if they didn't have hypertension.
Yeah. Yeah.
Unless
and this, of course, we learned before, the studies and everything about salt.
I mean, I can't say. Sorry, Carrie, I didn't mean to interrupt you, but
that's okay.
I always have to give a qualifier. Like, there's always that one condition that, yeah.
Well,
I mean, like if you have congestive, there's so many conditions where you would want to watch your sodium, but yeah, in just reference to either hypertension, no hypertension, and eating sodium.
Yeah.
Like just that in a nutshell. Not
my cardiologist wanted me to have at least 7,000 milligrams a day of sodium because of the orthostatic intolerance.
Oh.
Yeah. So for me, I'm supposed to be getting more.
Yeah.
Keep my blood pressure from going too low.
Wow.
That's why the whole thing at the dentist's office was funny. It's like, okay, well, I guess my blood pressure, my body does not like the dentist.
Right. We've established that.
Yes.
Okay. So other hormones and insulin resistance. Abnormalities in other hormones, namely leptin, resistin, adiponectin, amongst others, play a role in pathophysiology of insulin resistance and metabolic syndrome. Mitochondrial dysfunction, oxidative stress, and metabolic syndrome. Several bodies of research have highlighted the role oxidative stress and mitochondrial dysfunction play in the pathogenesis of aging and degenerative metabolic diseases. Mitochondrial dysfunction and metabolic syndrome. Mitochondria perform key biochemical functions that are essential for metabolic homeostasis, including adenose triphosphate, ATP, production. Now, hopefully I'll remember what that is. Adenosine
triphosphate. Yeah. So that's why, the Krebs cycle.
Mm-hmm. Yeah, that's your energy.
It's out.
It's
produced. Krebs, that's energy. Yeah.
Okay. So it includes ATP, energy production, shall we say. Mm-hmm. Intracellular calcium regulation. ROS.
Reactive
oxygen species.
Okay, I'm sorry, I didn't.
reactive
React-
oxidative species.
Oh my gosh.
Species, okay, species, reactive oxidative species production and scavenging. Ooh, okay, scavenging. Mitochondria also regulate apoptic, right, cell death as well as cell survival. The primary mitochondrial function is ATP synthesis through oxidative phosphorylation via the citric acid cycle, as well as beta oxidation of fats. The citric acid cycle.
The Krebs cycle, right? And that's the same thing as a Krebs cycle.
I think so.
Wow, I just never have heard it called the citric acid cycle that I can think of. I always think of citric acid as something that's in oranges or, in.
Yes, the citric acid cycle and the Krebs cycle are the same thing.
Yeah.
Okay.
Thing.
Both, in case anybody doesn't know, both names refer to the same series of biochemical reactions that occur within the mitochondria of cells, playing a crucial role in energy production during aerobic respiration, which it doesn't relate to like your respiration. It's like within the cell. But it's also known as the TCA cycle. So Krebs cycle, citric acid cycle, and the TCA cycle is all the same thing.
All the same thing.
Okay. All right. Evidence suggests that when there are alterations that arise in mitochondrial fission and fusion processes, this inhibits mitophagy, a process responsible for the elimination of dysfunctional mitochondria. Okay, so mitophagy means that it's getting rid of mitochondria that are no good anymore.
That aren't working anymore. Yeah.
This then results in reduced mitochondrial biogenesis. The mitochondria continuously metabolize oxygen and generate reactive
Oxygen.
shoot. Okay, I told you I'm brain dead. Yep, I don't remember the S.
Basically, ROS, that's what they refer to when you're dealing with oxidative stress.
Okay.
Is you've got too many ROS.
All right, and generate oxidative stress. Okay. However, in the process of electron flow, approximately 5% of oxygen consumed is incompletely reduced. Approximately 5% of oxygen consumed is incompletely reduced. This results in the production of ROS. Superoxide anions are thought to be primary ROS, and when they are generated in excess, they cross-react with multiple compounds in an effort to stabilize, in turn yielding a secondary ROS. Okay. These ROS further interact with nitrogenous bases in DNA molecules, thereby causing damage to the DNA backbone.
So the ROS basically causes like oxidative stress on your body, which causes like aging, wrinkles, gray hair, like anything. It's basically just like it's like the browning of your internal. It's aging. It's progressing towards death, and the more ROS that you have, the faster that you're going to go that way. That's why some people have more wrinkle, well, other than DNA, like some people just have genetics that they don't have as many wrinkles, but like that's why people who smoke more, they get more wrinkles, they get damage to, that's all from like reactive ROS.
Yeah, but it does say that it can end up further can damaging your DNA.
Yeah,
which causes other problems, like it can cause just multiple things.
And that's like why like smoking is damaging your DNA. It's causing damage to like what they would call like what is it above the epigenetic changes to your DNA. Like,
Oh, but
like
that's where the
exposure to,
environment affects
yeah,
what your DNA does.
yeah, like
Yeah.
because it actually damages it.
Mm-hmm. So
Right.
then it makes your DNA do something different. It looks at the blueprint and it says, oh, well, the environment's changed to this and it's causing this to happen now. I've been actually reading a really good book about, well, and listening to videos. I haven't read it that much in the book, but anyway, of a gentleman who had been a pioneer in that field, and it's really fascinating, about epigenetics.
Yeah.
Yeah.
Yeah. So Nina has a question. Does oxidative stress have anything to do with oxidative LDL? And I actually looked this up because I wasn't really 100% sure, but yes, absolutely. The free radicals, which is so the ROS, I think those are the same thing as free radicals, right?
Yeah.
They're just these things
It
that
sounds like it.
circulate and they damage your other cells. So
And
yes,
it's
the
the
free
reason why
radicals.
people take antioxidants, because you're
Right.
eating things with antioxidants or taking antioxidants can help to reduce that burden of, the ROS basically
Yeah.
on your body.
Yeah. So damaged. So, which is interesting that this question came up because even the LDL can be damaged.
So it says
By free radicals.
oxidized cholesterol occurs due to a chemical reaction with LDL cholesterol. This can lead to an increase in inflammation and plaque buildup in the walls of the arteries. Excessive oxidized cholesterol may lead to atherosclerosis and increase the risk of cardiovascular disease, among other health issues.
That begs the question with people that have high cholesterol that actually causes them damage, whether they have damaged LDL because of oxidative stress on the LDL.
Yeah, because if they don't have the oxidative stress on the LDL, then there's not gonna be a problem.
Right. I mean, we need the cholesterol, but damaged cholesterol, not so good. Yes,
Right.
it's the cycle of destruction. Is okay. Oxidative LDL, what I've been trying to decrease. Yeah, and it should decrease as if you get rid of the things that are causing all those free radicals in your body, then you should end up with healthier LDL cholesterol, replacing the damaged LDL. That's the thing with our bodies is that when we do have damaged cells, our body wants to get rid of them.
Mm-hmm.
So as long as everything's working properly, your body should get rid of the bad cells and replace them with good cells.
Yeah, I think the problem lies if you keep doing things that cause the cell damage, and then your body's just getting rid of more and more cells, and then the cells you do have are kind of limping along until they're eliminated, until they finally get to the point, they're not functioning at optimal capacity, and then they just finally get to a point where they don't function at all. So you're actually running out of good cells, I think, like
And
maybe at a faster rate.
That's why autophagy is good, because it, and whatever you can do, like fasting and stuff like that, to, increase autophagy, because it helps to get rid of all those damaged cells. And like it seeks, like your body seeks out to get rid of those damaged cells. But there comes a point where, if you're doing too much damage or you've got other things going on where, your body's not able to regulate it, that, it can cause all kinds of
people
problems.
who continue to smoke,
Yeah.
I mean, so many people that have smoked for a long time have atherosclerosis, and they end up with having problems with their heart and their vascular system.
Mm-hmm.
All right. No.
Okay. Excess ROS also damages vital mitochondrial enzymes and proteins, thus disrupting ATP energy production as well as essential functions in mitochondria. By the same processes, RNS are also produced. which similarly cause damage to cellular organelles and potent antioxidant production is reduced. So we can actually
Remember
produce
what
our own.
RNS is.
Hmm.
I need a reminder what RNS is.
Yeah, me too.
Let's see here.
Responsive. Well, I don't think it's responsive neurostimulation because that's an actual procedure.
Damage. Reactive nitrogen species. I don't know.
It could. Yes,
Let's
it is. I typed in RNS microbiology. Yes, in microbiology, RNS refers to reactive nitrogen species, which are nitrogen-based free radicals, which play crucial roles in host defense against pathogens and various biological processes. These include molecules like nitric oxide and its derivatives, such as peroxynitrate. RNS can damage cellular components, contributing to both beneficial effects like killing bacteria and detrimental effects like contributing to disease. So they have
a delicate balance.
Yeah, they have some positive and negatives. So, okay. So that's what RNS is.
Okay, let's see. So mitochondrial dysfunction by these mechanisms is implicated in each of the clinical conditions that make up the clinical diagnosis of metabolic syndrome. It is also important to note that various lifestyle processes contribute to ROS production and reduced antioxidants, like poor sleep quality and quantity, shift work, and chronic stress.
Yeah. Now, this is a question I don't know. How do you check
I don't think that you would need to. Like, you definitely have ROS and RNS in your body.
Yeah.
That's literally just a normal part of being a human.
Yeah.
It's just the amount based on what you do that causes more damage and can lead to conditions like cardiovascular disease, any disease, basically, cancer, aging in general. Like, it's not something you need to check for. It's more like you need to, do the right things like sleep, help your body to get rid of to process these things, Like, get good sleep, get good nutrition, exercise, just all that stuff.
Yeah. Because I'm old. Well, and we can't necessarily, we can always undo a lifetime worth of bad decisions, but we can do our best.
Yeah, and you can always make improvements on your mitochondrial function. You don't really see it directly. It's not like you can say, "Oh, I have mitochondrial dysfunction," but you can know that by like how you feel, what you're doing, what your habits are. You know that you're damaging your mitochondria and metabolic syndrome. Basically, if you have that, you have you have some mitochondrial dysfunction.
Yeah. And I think that's the point that they're saying here is that this is a part of mitochondrial dysfunction is part of metabolic syndrome.
Yeah.
You don't have
and that falls in with
mitochondrial dysfunction.
That falls in with Dr. Palmer too, like what he says about the mitochondrial dysfunction and mental health. I mean, and connecting that with with your metabolic syndrome and insulin resistance and all of that. I mean, your whole body is just connected basically, but it's interesting to see all these things and just like how you can read one explanation here and then it's like, oh, well, this is an explanation over here too, because oh goodness, let's see, good energy, Casey Means, when she was talking about like how doctors are so centered on, like their body part centered, like you have an ENT and then you have ear doctors and you have, that kind of thing. But really it all relates to everything. It's just that things have gotten so specialized now that they look at everything as separate, but it's all part of the same body. This is crazy. I don't know. I just like seeing the relationship. Like if I read an explanation in here, and then I know that we've seen it somewhere else and it applies to something totally different, or what we think of as different.
And the way they talk about mitochondrial dysfunction might be different in all these books, but it's all about, mitochondrial dysfunction, metabolic syndrome, insulin, what am I trying to say? Insulin
resistance.
Yeah. It's like, where's that word? I don't know. Wasn't here.
See if I can find it.
Yeah, I'll just reach out and grab something. So she was talking about peptides. Like, what kind of peptides are you talking about? There's a lot of different peptides.
Right. Yeah. Have either of you guys ever taken peptides?
Like, what kind of peptides are you talking about? Yeah. Insulin is a peptide. GLP-1 is a peptide. I mean, there are a lot of peptides. There are tons of peptides for like healing wounds. Like just about anything you could possibly have wrong with you, there's a peptide that you could take to help that.
Well, and that kind of goes back to the statement that peptides may help. So
yeah, I mean, peptides can definitely help you.
Yeah. So
cool. Interesting. All right. Well, I'll go ahead and give it a shot in reading at least the first part of this next section. Oxidative stress. Reactive species are essential signaling molecules in health. They play a physiological role in all bodily processes from cell division, growth, and differentiation to metabolic regulation, including insulin signaling, and are coupled with neuralization factors to maintain homeostasis. Reactive species. So that's the RO. Okay.
Yeah, reactive species, they're the RO. That's the ROS. Same thing.
Okay. I'm just wondering, okay, I guess because the sentence started with it, maybe because I'm like, well, why did they not abbreviate it there? Okay.
Oh, yeah, good question.
Yeah. In the physiological state, homeostasis is maintained through highly efficient and synchronized processes of reactive species and antioxidant production, as well as the removal and repair of damaged molecules. However, in the presence of nutrient excess, all nutrient metabolic pathways are overwhelmed and the metabolic redox equilibrium is disrupted. Okay. For example, in glucose excess, the accumulation of glycolytic metabolites activates alternate pathways for glucose metabolism, namely the polyol, hexosamine, and advanced glycation pathways. This in turn increases reactive oxidative species and nitrogen species, NS, like I'll remember that, production. With regards to the polyol pathway, nicotine, oh Jesus, okay, nicotine.
NADPH.
Yeah, we'll just say that. NADPH is depleted, which is associated with a reduction in glutathione, as well as insulin resistance related to insulin resistance syndrome 1 tyrosine phosphorylation. Yeah. AKT. Phosphorylation activation. I didn't know whether that was pronounced as a word or initials. AKT.
Oh no, I don't know what that AKT is.
Yeah. Okay. Phosphorylation activation and GLUT4 expression. Okay. Okay, so what did we just read? Or what did I just read? Okay, so we know that when there's too much glucose, there are alternate pathways for glucose metabolization. Okay.
So it sounds to me like it's talking about a lot of things that can help counter the ROS also. If
Although it does say that using these other pathways and these advanced glycation pathways increases ROS and the nitrogen species production.
Mm-hmm.
So it basically, I think the point is that when you eat too much, this is one example. When you eat too much, you have too much glucose, and it has to use these other pathways to break down the glucose. It actually results in increased reactive oxygen species and nitrogen species production.
Yeah.
Which is one reason why eating too much and having too high glucose causes damage.
And then you do that over prolonged periods of time and it just gets worse and worse.
Right.
So like doing it once is probably like once a month probably isn't going to hurt anything. But if you do it every day, consistently.
So
yeah.
I know that glutathione.
I was talking about it reducing glutathione. Glutathione is an antioxidant. So if you have reduced glutathione, you're not breaking down those free radicals like you should be.
Yeah.
And so they're causing damage.
What you have with mitochondrial dysfunction, that's one thing that my doctor, she diagnosed me with mitochondrial dysfunction and metabolic syndrome. And she also gave me glutathione because it is such a potent antioxidant.
That's what I take that as well.
Really?
Yeah. So for me, it's because I have the MTHFR variant. And so my homocysteine levels are high because my body doesn't break them down into the glutathione. And so I take this called homocysteine supreme, and it has the glutathione already broken it down to the form that my body can use.
Oh,
but
wow.
They suspect that that's why I tested positive for the mycotoxins, because that's one of the things that will help break down the mycotoxins in your body is the glutathione. But mine were building up, not, and it wasn't my environment because our house tested clean and everything. Yeah. So it was just me.
And I don't know what I was going to say now. Oh, I'm almost 50, y'all.
Hush, I don't even know
I got something on the AARP over here on my counter that says that I'm going to get forgetful now.
Oh, no. That's not an excuse because we're both older than you.
That's right.
Oh, yes. Meeting with the naturopath tomorrow. Yes. So talk about, all this stuff.
I may try that. I mean, just to, I don't know. I mean, I experiment with stuff every now and then just to see if I notice anything.
Well, have you had the genetic testing?
Nope.
So have you ever done 23andMe or Ancestry.com?
I've been thinking about doing it, but I just haven't yet.
Yeah.
So. Well, I did the 23andMe and I have the same. I have one of the MTHFR. There's like 2 different variants that you can have that are kind of problematic, especially for you. It inhibits it interferes with a lot of things, but one of the main things that it interferes with is you being able to methylate
B vitamin, folic acid,
or any vitamin. So like if you take a vitamin, it needs to be a methylated form of like B12. You'd have to take like methylfolate instead of folate.
Yeah.
And then, anyway.
Yeah, I found this out, the significance of it for me after I found out that I had high homocysteine and low folate levels when I had blood work done.
Yeah, I don't have low folate levels, but I don't know. but I do have the MTH FR variant, one of the variants.
Yeah.
And I think that's what causes my problems with probably with my candida and,
Yeah, I remember I had like 30 some variants. So, which I don't think is abnormal.
I think there's only 2 that are.
No, not just the MTHFR. I mean, about all the genetics. I had like 30 some different variants, but a lot of them affected similar.
Amy's so special. Look. She said she has both of them.
Yes.
Oh, wow.
She's an overachiever.
I don't know. Maybe you need to go to the right kind of doctor. I know.
There's not a whole lot, Amy. Honestly, there's not a whole lot that that a doctor is going to tell you to do about an MTHFR variant. Mainly, they're going to tell you if you need to take, a vitamin, make sure it's a methylated. Like if you need to take like B12 or folate, make sure it's a methylated.
Yeah, my doctor gave me specific things to take.
Well, you can do glutathione. You can do. There are a few things that you can do, but for the most part, treating your body well by eating the right food can go a long way to reducing your ROS to begin with. And, it's a very expensive thing that you have to do if you get, if you go to see these naturopaths and these functional medicines doctors, I mean, it's thousands of dollars So
yeah, like Dr. Berry talks about that, just kind of being aware because of being told to take a bunch of supplements and stuff.
Mm-hmm. And that's another thing is they all sell. Yeah, they all sell the supplements that they want you to take. So it's I always tell them, okay, thanks. I'm not going to buy the supplements from your page there. So just let me know which ones I need to get.
And I'll go source them out myself.
Because that's a conflict of interest in my opinion.
Yeah, and you can always pick and choose because I do believe some supplements can definitely be beneficial for you. It's just that when I had a friend who went to a naturopath doctor and my God, the money she got those tests, the food allergy tests that Dr. Berry talks about. She had that done, and then they basically said she was allergic to all kinds of meat and everything. I mean, so basically wanted her to go on a vegetarian diet.
So the IgG blood testing is what they do for food sensitivities.
Yeah.
And I think it's total BS. And Dr. Berry agrees with that. Yep. And what it is, and this is what Dr. Berry says it is basically it's not necessarily what you're sensitive to. It's that everything you put in your body has some sort of response to. So the things you eat the most are what you'll find that you're sensitive to,
Mm-hmm. Yeah.
So it's I don't really, all the stuff that it said, there's one thing that I think that might have been accurate. And I mean, I think that's a coincidence, but, and that was casein in milk, which a lot of people are reactive to that, but I don't think that test necessarily found it. I think that, I don't know. It's very uncertain science, put it that way.
I kind of figured out the milk issue myself because years ago, because if I didn't already have something in my stomach when I consumed the milk, it made me feel ill.
Oh,
just like my dad is lactose intolerant. So, I mean,
my daughter too. She tried, she's been carnivore now for about 3 weeks, my daughter and son-in-law.
Oh, really?
Yeah. And she tried probably a little too early, tried a little bit of dairy because she's got it. Yeah. And she said it wasn't as severe as before, but she still had numbness in the bottom of her face.
Oh, wow.
Yeah, probably a little too soon. Yeah. She'll get her lips will get tingly and numb and her tongue. And so she tends to avoid dairy.
Mm-hmm.
Yeah, but she didn't used to be allergic. So Amy says, I figure that the two together would cancel each other out. Yeah, if only.
Right.
Your naturopath. Oh, that's awesome.
That's good. That is really good.
Yeah. Man, mine's not, but he's supportive of my being carnivore. And now that he's seen all the results and stuff, he's much more happy, to support it.
Yeah.
So,
all right. Well, let's see. I'll at least finish this paragraph here. Okay. Glutathione is a potent cellular antioxidant, so its reduction contributes to the overall reduction in antioxidant capacity and oxidative damage. Thus, excess glucose ingestion overloads oxidation pathways by enhancing free radical production as well as impairing oxidant defense mechanisms by reducing their availability. In insulin resistance and metabolic syndrome, physiological states usually characterized by excess glucose ingestion, glutathione exhaustion, and oxidative stress overload are both inevitable exacerbators for these diseases.
Interesting. All right. You want me to finish this section and then we can call it a wrap?
Yeah.
Okay.
Yeah, because
I got to cut it at an hour tonight. I can't go much.
Oh, okay. Well,
Yeah.
we can just stop here.
I'll just quickly finish this section.
That's
Hopefully
fine.
it'll be clear as mud, as it usually is.
Okay.
A further metabolic consequence of glucotoxicity is the oxidative carbonyl and glycation stress caused by advanced glycation end products and other metabolites such as reactive carbonyls. AGEs, or advanced glycation end products, when bound to specific cell surface receptors of RAGE, so those are, as RAGE, I guess, are the receptors, result in alterations in signaling pathways and promote intracellular reactive oxygen and nitrogen species production. There's recent evidence to suggest that common stress signaling pathways, nuclear factor kappa B and NH2 terminal big word, are all central to the development of diabetes complications. So when white adipose tissue storage becomes overwhelmed due to excess nutrient intake, increased free fatty acids circulate and deposit as visceral fat in the liver, muscle, pancreas, as well as ectopically, resulting in lipotoxicity and resultant oxidative stress and damage, as well as insulin resistance. Aside from the obvious impairment of efficiency of each organ, FFA delivery, or for free fatty acid delivery, and fatty acid oxidation in muscles have been hypothesized to increase acetyl-CoA/CoA and NADH/NAD ratio. This in itself has been postulated to inactivate glucose 6-phosphate, thus inhibiting hexokinase 2 activity and a resultant increase in extracellular glucose, followed by reduced glucose uptake and glycogen synthesis. In the setting of lipotoxicity, there is an accumulation of fatty acids and other lipid metabolites, namely diacylglycerol, ceramide, and lipid aldehydes, which increase oxidative stress via numerous intracellular mechanisms. DAGs directly activate protein kinase C, or PKC, and other serine threonine kinases, which results in the impaired tyrosine phosphorylation of insulin receptor substrate and insulin signaling. There are numerous sources of cellular oxidative stress related to lipotoxicity and calcium signaling, including mitochondrial impairment, endoplasmic reticulum stress, as well as various kinases, AGEs, INOSs, oxidases, xanthine oxidase. Likewise, as a consequence of multiple cellular oxidative stress sources, a vicious cycle of insulin insensitivity and impaired insulin secretion develops. So one last little section here. Do you want to stop here? Because then we can have the next time we can look at the diagram.
Yeah.
I don't want to read this and not look at the diagram.
Yeah.
Okay.
So
all right. That was a lot.
That was a lot, but I learned a lot too.
Yeah.
Yep. I'm
Definitely.
retaining a little bit from here and a little bit from there. So
Yes, definitely.
And the more we read it, and I think a lot of this stuff will probably be rehashed. And I know some of this, of course, was in prior discussions. You know, when we discussed different cycles, like with the liver and all of that, I know that, you know, like just the whole cycle in general. So it's just repetition, just more and more exposure.
Yeah. So what's your schedule next week, Kim?
next week I start working on Tuesdays. So,
Okay. So we'll figure out a different day.
Yeah.
Yeah.
Let's see here.
And I'm sure I'm available.
Yeah, it'll be just.
I'm available. I think Wednesday if we wanted to do Wednesday. I'm pretty sure.
All right. Well, we'll figure it out and get something scheduled for next week. I'm going to have to look at next week's schedule for Healing Humanity Life and see what we've got going on.
Yeah. I almost never work on Wednesdays. That's almost, I'm a nurse. We always, it's never set in stone, but
yeah,
out of the next, probably 10 Wednesdays, I think I work one of them. So,
okay. So maybe Wednesday we'll end up working out.
Okay.
So,
okay.
Cool. Well, we'll get it nailed down and figure it out. Thanks everybody for joining us in this complicated material that we're trying to wade through. And we will see you next week.
Yeah.
Bye, everybody. Have a great week.
All right. Have a wonderful week.